All right, so reasoning. So we're still in section 1.1. Now we're looking at reasoning. Success in the study of geometry requires vocabulary development, attention to detail and order, and supporting claims and thinking. Reasoning is a process based on experience and principles that allows one to arrive at a conclusion. So we've got a couple different ways that the following types of reasoning are used and develop mathematical principles. So a couple different ways we can kind of look at reasoning. We can have what's called intuition. Intuition is an inspiration leading to a statement of a theory. So you got just an inspiration that's going to drive you there. Induction is an organized effort to test and validate a theory. So you have a theory and you organize your way through to be able to get to test to see if you can validate that theory. Versus deduction is an argument that proves the tested theory. So you already got a tested theory and you form an argument to use that to deduct your way through to that definition or to that scenario. Sorry about that. Pause real quick. All right, intuition. We are often inspired to think and say, "It occurs to me that." With intuition, a sudden insight allows one to make a statement without applying any formal reasoning. So in my little image over here, I'm right because I feel right. Like that's kind of the idea of intuition, right? When intuition is used, we sometimes err by jumping to conclusions. So in the cartoon, you see that we have this bright idea using intuition. It's shown with a light bulb next to their head, or something to kind of like show, like, oh, I got it. So, like for example, here, if we used intuition, we might find error. So we call this a regular pentagon because it has 5 sides that have equal lengths and it has 5 interior angles that have equal measures. What do you suspect is true of the lengths of the dashed lines from B to E and B to D? Pause and then you can come back when you think you got it. All right, welcome back. Let's see. All right, so with intuition, it suggests that the lengths of the dashed parts of the lines, known as diagonal of the pentagon, are the same. So one, using induction, we could use a ruler. So the difference would be is like if we use intuition, we just suggest, we just be like, oh, they got to be the same. All right. If we used induction, we'd actually use a ruler. We would actually go through and we'd verify that our claim is actually true. Whereas if we use deduction, we could prove that the two diagonals do indeed have the same length. So we could work our way through the process. So with induction, if we go back to those definitions one more time, with induction, we organize a way to test, to validate our theory. Whereas with deduction, we form an argument. We work our way through an argument. So in that, we'd use like mathematical deduction, where we would like go through and like use some like rules as far as like triangle congruences and stuff like that to be able to identify that these were actually equal. All right. I think I'm going to stop there with that one.